the distance formula. So that is going to be our lesson. Okay, so the distance formula is used to find distance between 2 points. So if we are given 2 points, x1, y1 and x2, y2, the distance between these 2 points is given by the formula d equals to the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So if we are asked to find the distance between the 2 points, -2, -3, and -4, 4, using the distance formula, we will just plug it there. So our x sub 2 is -4 minus x sub 1, -2. So that's -4 minus -2. And our y sub 2 is 4 minus our y sub 1, -3. So that's 4 minus -3 squared. Simplifying, we have -2 squared plus 7 squared. Okay, so that is 4 plus 49, or that is the square root of 53. Then the distance is the square root of 53, or when you extract the square root of 53, that's approximately 7.28 when we round off to 2 decimal places. So again, in this subject, we're going to round off all our answers in decimals to 2 decimal places. You just have to be cautious in dealing with the values of x and y. So the most common mistake is when you're going to use the formula, you accidentally mismatch the x's and the y's. So don't subtract an x from the y. Be careful with that, and vice versa. So make sure that the pairing is correct, or the pairing is proper. Next example, find the radius of the circle given that the center is at 2, -3, and the point on the circle which lies on the circle is -1, -2. So to find the radius is the distance from the center to any point on the circle. So we can use the distance formula. So plugging it here, so we have 2 minus -1, so that's 2 plus 1, that's 3. -3 minus -2, that is -1, so that's 9 plus 1 is the square root of 10. Then the radius is the square root of 10, or approximately 3.16, rounded to 2 decimal places. Next example, find all points for y that are 10 units from the point -2, -1. So 10 is already the distance, and you substitute the 2 points and the distance in the distance formula. Okay, so you have these 2 points, only that the y is unknown. So you have -2 minus 4 and -1 minus y, and our distance is already given as 10, so that's 10 equals the square root of -2 minus 4 squared plus -1 minus y squared. Simplifying, we have 100 here, so 10 equals the square root of, this is -6 squared plus, simplifying this one, so you are squaring a binomial, so you have 1 plus 2y plus y squared. So you have 36 plus 1 plus 2y plus y squared, and that is y squared plus 2y plus 37. Now we square both sides, we can get the variable 10 squared equals y squared plus 2y plus 37. So we have 100, and you remove the square root here, so you have transfer 100, or transpose 100 to the other side, so you have 0 equals y squared plus 2y plus 37 minus 100. We are doing this so we can we can factor out when we simplify the right side. So simplifying the right side, we have y squared plus 2y plus 63. So when you factor this out, you have the factors y plus 9 and y minus 7. This means that your y, so if we are going to extract the y, so that's y plus 9 equals 0, equating each factor to 0, and you have y minus 7 equals 0, so you have your y equals negative 9, and your other y is equal to 7. So the 2 points is 4, negative 9, and 4, 7. Okay, so that's another application of the distance formula. Then we have this one. You're going to find the length of the sides of the triangle given the vertices A, negative 2, negative 3, B, 6, 1, and C, negative 2, 5. And identify what kind of triangle is triangle ABC. So, we need to find distance between AC, AB, and BC. So, we will identify what kind of triangle is triangle ABC. So, we have AC, so we have okay, so when we are going to use this one, so our AC is from point A to point C, so we have the same excess, so we don't need to use the distance formula, so we just have the abscissa, so you just have to subtract 5 minus negative 3, or that's 5 plus 3. Okay, and that is equal to 8. Okay, so why are we not using the distance formula for AC? Take note that they have the same x coordinates, abscissa. So we just have to subtract the y's. So 5 minus negative 3 is equal to 5 plus 3. That is equal to 8. Then for AB, we have 6 minus negative 2, so that's 6 plus 2, and 1 minus negative 3, or 1 plus 3, so that is 6 plus 2 is 8 squared plus 4 squared, so that is 64 plus 16, so that is the square root of 80, or that's 4 square root of 5, so square root of 80 is 16 times 5, or that is 4 square root of 5. Then for BC, we have negative 6 minus negative 2, so that's 6 plus 2, and 1 minus 5 is 4, negative 4, squaring that you get square root of 80, or 4 square root of 5. So notice that the two lengths AB and BC are equal, so we could say that triangle ABC is an isosceles triangle. Remember the definition of an isosceles triangle? An isosceles triangle is a triangle whose uh, two sides are equal. Okay, so that is for our lesson on distance.